Let's talk today about solving some quadratic equations by graphing. To get started, let's go back and do a really quick review of some quadratic functions. What a quadratic function is. Standard form is y equals ax squared plus bx plus c. We know that the f of x can interchange with the y, so if we take the y out and put f of x in there, that's just a statement that says for sure that this is a function. We also know that a, b, and c are real numbers. A cannot equal 0. You should remember how to find the axis of symmetry of a quadratic function. Remember, an axis of symmetry is a line, so it has to be written as an equation, x equals negative b over 2a. That negative b over 2a value is also the x-coordinate of the vertex. We take that value, substitute it back into the equation in place of x to find the y value of the vertex. The y value of your vertex is your maximum or minimum value of the function. Also keep in mind that y-intercepts all have an x value of 0, so if you want to find the y-intercept of a quadratic function, you put 0 in for x, which means that this value will always be c. Okay, so that's just a little review. We're going to go back, and since we're going to solve these today by graphing, we need to make sure that we can graph quadratic functions. So in order to do that, the first thing you're going to do is you're going to find the axis of symmetry. Remember, your axis of symmetry is the opposite of the b value divided by 2 times the a value. So very quickly, we're going to use this top equation. Our a value is 2. Our b value is negative 4. And our c value is negative 3. So the opposite of b divided by 2 times a gives us a value of 1. So our axis of symmetry here is going to be x equals 1. That is a dotted line right here. Okay? We know that our vertex is on that line. So our vertex is going to be 1. And then we'll substitute a 1. We'll put a 1 in here. We'll put a 1 right here. So that's going to give me 1 squared is 1 times 2 is 2. 4 times 1 is 4. So that's going to give me negative 5. Is everybody okay with that? So 1, negative 5. 1, 2, 3, 4, 5. My vertex is right here. I know since my a value is positive that my parabola is going to open up. So I just need a couple of points on one side. One good one would be to use the y-intercept. Remember, a y-intercept, the y-intercept is 0, and then whatever the c value is, the c value here is negative 3. So the y-intercept is 0, negative 3, 1, 2, 3. Its match is right here. I need another point. So how about I put negative 1 in for x. So that means I'm going to put a negative 1 here and a negative 1 here. So negative 1 squared is 1. 1 times 2 is 2. Negative 4 times negative 1 is positive 4 minus 3. So that's going to give me a 3. So I'm going to also use the point negative 1, 3. So negative 1, 3 is right here. That's 2 places to the left of the axis of symmetry. So I'm going to put it 2 places to the right of the axis of symmetry. Okay? And then I'm going to simply go like this. And what we'll be looking for next will be the zeros of this. Let's talk about that really quickly. Zeros of a function are the same thing as the x-intercepts. Okay, so if I go back to this, my zeros are going to be right here and right here. Now, this is one of the problems with graphing, is that sometimes it's hard to determine exactly what the value is, because it's not exactly, it looks like it's close to being, 1, 2, maybe 2.5 here, and close to being negative 1 here, but I know it's not negative 1 here because this is negative 1. and this is a function, so those can't be right above each other. All right? Now, I put this one down here because what I want you to see is 1, 2, 3, 4, 5. If I were to graph this, it would look just like this. It would just be the reverse of this because all I did was change all of the signs. So it would look just like this. These will both have the exact same x-intercepts. It's just one parabola opens up, the other one opens down. Okay? All right, so here's what can happen. When you graph a parabola, one of three things can happen. It can look something like this, which means it has two zeros or two x-intercepts. It could flip over like this, in which case it still has two x-intercepts. It could, I can't make it move. It could be something like this, in which case it would only have one x-intercept, and that x-intercept would be the vertex. Okay? And the third thing that can happen is that your parabola could be up here, or I'm having fun with that. Or it could be down here, something like that, in which case it has no x-intercept, so it has no zeros. And now we're just going to go ahead and do these. Okay? Now every quadratic function has a related quadratic equation. Notice these two right here. What did I change? The y has turned into a 0. This is an equation. Okay, this would be something I can graph because it's got two variables. It's got the x and the y. And this would just be an equation I could solve. I can solve this quadratic equation by graphing this quadratic function. Okay? Again, keep in mind, all x-intercepts have a y value of 0. So when I put the 0 in here for y, I am actually solving for the x-intercepts. And this is how we do this. We're going to solve this one by graphing the related function. You'll notice that this is a 0 here. So the first thing I'm going to do is I'm going to take that and I'm going to put a y in there. So I'm going to put y is equal to 2x squared minus 18. And I'm going to graph very quickly. I'm going to find the axis of symmetry. My b value is 0, so the axis of symmetry is going to be x equals 0. That means my vertex is going to be 0, negative 18. Okay? I put a dot right here for my vertex, which is 0, negative 18. Now I need two more points. So I'm going to pick the values. I'm going to pick actually 2 and 3 for x. All right? So when I put a 2 in there, 2 squared is 4. 4 times 2 is 8. It gives me a negative 10. So 2, negative 10, 2, 4, 6, 8, 10. Okay? Counterpoints right there. And then how about if I use 3? 3 squared is 9 times 2 is 18. That gives me a 0. So 3, 0. And that would be right here. Okay, so you can see my parabola is going to go right up here. Okay. And then on this side, right up here. Okay. Remember, we are looking for the x-intercepts. They're right here and right here. So if I wanted to solve this equation by graphing, these would be my solutions. 3 and negative 3. Okay? Now I just want to show you something very, very quickly. If you were to solve this algebraically, add 18 to both sides, divide by 2, take the square root, those would be the exact same answers you'd have gotten. All right, so let's do two more here. You should pause the video and do this one on your own first. All right, so we find the vertex, which is going to be 3, 0. Put a point there. Okay, find two other points. I've got 2, 2. and I have 0.18. Okay. Again, remember that you have an axis of symmetry that goes right down the middle. So these guys have matching points on the other side, and your parabola is going to look like this. Okay, and just sketch it on up there. And in this case, there's only one 0, and it happens to be the vertex. Okay, last one. Stop it and do it again. So you're going to find the vertex, which is at -1, 1. You're going to find 2 more points. The y-intercept was available, so I'm going to use that, 0, 3. And again, his match is right here. And then I put a 1 in there for x and got a 9. And again, his match is right here. And then this parabola will look like this. And in this case, there are no zeros or no x-intercepts. And that's it.